in this notebook, just set use sample equals true. So let's say if we set use samples equals true, and then we pick a fraction of the data that we want to work with, then all we are doing here is we are setting raw df, the data frame that we have created, to a sample of the data frame. So we are setting raw df to raw df dot sample, and we have the fraction, sample fraction dot copy. So we are basically taking a 10% fraction, and instead of using 140,000 rows, we would just be using 14,000 rows, and that will make our training or our analysis much faster. In this case, not by so much, but if we had like 10 million rows, then it would make a lot of sense to maybe just work with 100,000 initially, set up the notebook, and then come back and change use sample back to false. And if it's false, then we won't pick a sample, and then rerun the notebook from top to bottom. Okay, this will save you a lot of time when you're working with massive data sets. So always set up these 3 lines of code: use sample, sample fraction, and this if else condition, which you can easily switch between having a sample and working with the entire data. So that's a quick trick there. All right, so moving right ahead, before we train the model, we have to learn a few best practices. So we are going to learn a few best practices that now you will start to see coming up over and over again with every model we build. Now, while building real-world machine learning models, it is quite common to split a data set into 3 parts. The first part is the training set. And the training set is used to train the model, which means that we take the inputs from the training set, put them into the model, which is randomly initialized with some random weights. We then take the outputs or the predictions of that model, compare them with the targets, the actual targets, and compute a loss using a loss function. And then we put them through the optimizer to change the model's weights using an optimization technique. So that's machine learning. That's a machine learning training workflow. The training set is used to train the model. But remember that your model is not going to be used on the training data. The training data in this case, for example, is historical data, but we want to use the model on new data. So it will not be accurate to report the model's performance on just the training set. And that is why we create 2 other sets. We create a validation set and a test set. Now, a validation set is used to evaluate the model during training, because training is often not a one-step process. Often you train a little bit and then see if you got a good enough result, maybe train some more, maybe you change some parameters in the model. Maybe instead of using a logistic regression model, you use a polynomial logistic regression model, or maybe you change the optimization algorithm. Maybe you change from least squares to gradient descent to bilinear solver, etc., right? So while you're training the model, you will want to experiment with a lot of different tweaks to the model structure itself and to the optimization process itself, or maybe even to the loss function. You can even change the loss function. So as you want to tune all of these different ways of training the model, you should be using what is called a validation set, which is simply a fraction of the data set. And you shouldn't use it to train the model, but you should use it to evaluate the model, which means that once you have trained the model using the training set, you then make some predictions on the validation set and simply check what the score on the validation set is. So instead of now using that score to once again train the model or improve the weights, you don't do that. You use just a training set for training, and you use the validation set simply for checking how well the model is doing while you are still experimenting with the model. And picking a good validation set is an essential, a very essential, probably one of the most important parts of a machine learning project, because you want your model to generalize well. And you can learn more about it here. I've linked to a blog about picking good validation sets. And then finally, there is a test set. So then there's a third set, and this test set is used to compare different models or compare different approaches by different people. For example, you have certain data sets which are public data sets that are used by researchers around the world. Now, with these data sets, if everybody reports their accuracies or their performance on a different validation set, maybe somebody picks the first 10% of data, somebody picks the last 10% of data, somebody picks a middle 10% or a random 10%, then those results will not be comparable. So that's why typically it's a common practice to standardize a test set for a data set. And you will often see that you will get a training data and then you will get a test data. So when you have training data, you split it into training and validation, but the test data is what is standardized, and you're not supposed to use it for training. You're not even supposed to use it for validation. You should only use it at the end to report the model's final accuracy. And for many datasets, test sets are provided separately. And then in a lot of cases, for example, in Kaggle data science competitions, you are not given the actual targets for the test set. So you are simply given the inputs for the test set, and you have to then make some predictions for the test set, create a CSV file with your predictions, submit it to Kaggle, and then Kaggle will compare them with the actual data for the test set and then give you the result or give you the score. So this is called a hidden test set. And a lot of companies tend to do this as well. As a data scientist, when you're given a project, you will not be given the entire data. So you'll be given maybe 80% of the data with labels, and then you will be given another 20% of the data with the labels hidden from you. So you will then, once you train all your models, you will take that 20% of data and you will make predictions, give it back to whoever has given you the project, and they will tell you how well your model is doing in the real world. Okay. So it's a very important piece of machine learning, and you will often see when you start out with machine learning that the models that you train perform really well in training. You get to like 98, 99, 100% accuracy. But when you put them out into the real world, they get like 30, 40% accuracy. And this phenomenon is called overfitting, where your model is optimizing too much for the training set. So to give you an analogy to think about the training, validation, and test set, think about how school works or how high school works. So now in India, we have 12 grades, and in grade 12, what happens is you have a textbook and you have classes. So you read the textbook, and in the textbook, for example, for a maths course, in the textbook, you have some questions. So now you solve the questions in the textbook and you use that to improve your understanding of mathematics. And one way to do it is to actually learn the concepts, but the other way to do it is to simply memorize the answers, right? And your model, because you are simply trying to optimize for the lowest possible loss, your model over time will start memorizing training examples. Just like in a lot of school systems, people start memorizing answers to questions. So to avoid blind memorization, what people tend to do is schools conduct exams. So schools conduct a midterm, schools conduct quizzes. So they conduct exams at various places during the school year. And you can think of that as the validation set. So that is where the model or you face questions that you have not already solved. And obviously your performance is a little bit worse, but more importantly, you need to learn the actual concepts or the underlying relationships rather than simply memorizing answers, right? So that's the validation set. But then you have these board exams, or what you might call the SATs, which are used to compare the performances of students across the nation or across the world even. So you can think of that as the test set. So that is like at the very end of your school year, you have to give this one exam, and everybody in the country will be ranked based on that exam. So that's the training set, validation set, and test set. Training set is what you use to learn. Validation set is what you use to improve yourself and change your approach while you're still building a model. And the test set is to report your final performance. Okay. And as a general rule of thumb, this is not set in stone, but as a general rule of thumb, you can use about 60% of the data for training. You can use about 20% data for validation and 20% for test. And this is typically good enough if you're working with let's say tens of thousands of rows or hundreds of thousands. If you have more data, millions of rows, then you can shrink the size of your validation and test sets and use more for training. If you have less data, then you may have to even keep a larger fraction, but it really depends on problem to problem. And if a separate test set is already provided to you, let's say you're given a training set and a test set separately, then you can do a training validation split, which could be like a 75-25 or a 70-30 split. So typically this pick or this division of the validation and test set is done randomly, especially when the dataset does not have any inherent order. So if you have just random datasets or random rows in the data, it is very common practice to just pick a random subset of rows for creating the test set and the validation set. And this can be done using the train test split utility from scikit-learn. So we import from scikit-learn.model selection train test split, and you give train test split the data that you want to split. So in this case, we want to split the raw DF, the entire data set that we have. And we want to extract out first 20% and set that aside as the test df, so as the test data frame. So I'm just setting test size equals 20%. Now which 20% do we want to extract?